So, first of all, we need to talk about something called the geometric mean. Okay? When you think of the word mean in math class, okay, the mean, what do you think of? What do you typically do? Average. You add them up and divide by however many there are, right? Today you get to learn about a new mean because you're in geometry class and this is the first time you've ever seen it. Okay? This mean is called the geometric mean. Okay? And to find the geometric mean, if we have a number x that's the geometric mean between two numbers a and b, then what we do is we don't add up a and b and divide it by 2. Okay? The geometric mean is defined as a over x equals x over b. So write this in. Okay? In our normal language, my sister's mean to me. My brother's mean to me.
No, it's not that.
So, normally, arithmetic mean. It's not what I'm thinking. We add them up and divide by however. Okay? The median is the one that's in the middle, right? And the mode is the one that occurs the most often.
And then what's the one where you do the biggest minus the range?
That's the range. Okay? So mean, median, mode, range are all things that you saw in Algebra 1. You saw it before that as well. But we're not doing that mean. Okay? So this is called the geometric mean, and it means that it is not the middle. Okay? It is the number that when you square it, it's equal to the product of the other two numbers. Okay? So if a and b are the two numbers I'm trying to find the mean of, I end up writing it as a proportion. A over x equals x over b. It'll be okay for now. Okay? Joe.
You're going to set a magnet in the door and tell me it's the same everything.
It's not.
Same.
Thank you.
Is this legal? This is a fire.
Okay.
No, I'm actually sweating.
Well, if there's a fire, how we all need to be through a closed door?
No, it's too cold. Okay, can we change?
No, all right, guys, come on. Focus. We're gonna open it back up.
Yeah,
in just a little
Sophie's right.
bit.
Sophie's right.
Okay. Okay. So here we go. Now, when I do the mean, when I work with the mean, I don't want to set up the proportions. I get lazy. And I say that if x is the mean, then x squared will be equal to a times b. Okay, so you can set it up as proportions. The key to setting it up as proportions is first box.
Why?
Your x's have to be on the same diagonal, and your a and b have to be on the other diagonal. So when you cross multiply, you get x squared equals a times b.
So just the Pythagorean theorem?
Nope, not Pythagorean theorem, but similar because we have to simplify, right? We're going to take the square root of x squared to get plain old x, and that means we take the square root of the right side as well.
So then what is a b squared equal?
Okay, so let's look at it with some real numbers. Did everybody have this written down so far?
No.
I don't know.
It's in the first box.
We're on the white one.
On the similar right triangle side, very first box.
Okay, next.
You can take right, you can pick, tractor.
All right, everybody have that written down? Okay. All right, so let's work on this first one together. We have 4 and 9, and we want to find the geometric mean between 4 and 9.
More people are walking by.
They're almost gone.
Maybe you should just open the window.
So, if we want the geometric mean between 4 and 9, we say x over what
4
equals what over
9
over x.
Yes, if you want to write the proportions. You don't have to write the proportions for me. Instead, you can say x squared equals
436.
Oh,
4 times 9, which is 36, right?
yeah.
What's the square root of 36?
6.
6.
So x equals 6.
Yes.
Good job, Sophie.
6, 4, and 9 would make a right triangle.
Okay,
I should know that.
so far so good? Okay, next one. Now we want to find the geometric mean between 3
I
and
bet you have to
15.
do the same thing.
We do the same thing.
Oh,
Do you want to write the proportions?
yeah.
Okay, so what over what?
Let's do 3 over
X
x
over 3. X over 3.
equals 15 over x squared.
So you can write the 3 on top and the 15 as long as they're on the diagonal.
You don't have to.
This before, didn't we?
I don't think you've ever seen geometric mean before. We did set up proportions, yes, and we cross multiplied and solved. Yep, back in chapter 8. Okay, so x squared equals, now let's not multiply them together. No, don't actually multiply them out. Let's just take 3 times 15. Okay,
36.
45.
it's going to be 45, but watch what happens if we don't multiply it out. What is 15 the same as?
3 times 5.
To do all of this stuff.
3 times 5, right?
Yeah.
What's our perfect square?
2,
Let's take 3 times 3 square root all of it.
3 square roots of 5. When it comes out nicely, great, we can take the square root of 36. But if it's not going to come out perfectly, there's no sense in multiplying them together to get 45, only to break them back apart, right?
Yep.
So this is 3 times 5. We've got a pair of 3s. They come out as a 3, and we have a 5 that doesn't have a mate that stays inside. Make sense? Okay, next one. 2 and 10.
Dozen.
Is it
10.
2 square roots of 5?
X squared is going to be 2 times 10 now, isn't it? And 10 is 2 times 5. So there's my pair. X will be 2 square roots of
I see you, Sophie.
5. Okay, hello.
What?
Not necessary.
Oh.
Okay? Questions on those? Okay? So, first 2 are going to come out perfectly in your assignment. The rest of them will have some radicals potentially. Okay? So that's what you're going to be doing with numbers 1 through 8. Okay? Now, let's talk about how we use the geometric mean. Okay? What kind of triangle do we have here?
3
Right.
sides, 1.
A right triangle. Okay? We have a right triangle and it has 2 angles.
Isosceles.
We don't know if it's isosceles, right?
The angles are equal
Because-
though. Look.
Does it look like the angles are equal?
Yep.
I see a bigger angle.
Why do they both have?
Notice how this
But they
doesn't,
both have curves on
they
them.
do have curves. I can make it more obvious, right? So this one might be more like isosceles somewhere, but it's definitely scalene.
Wow.
Okay? So far so good?
So,
Wait, what?
Okay, so we have a right triangle. This right triangle has 2 angles. This is just an explanation to show you. Okay? So we have a right triangle with 2 angles, a red angle and a blue angle. Okay? Watch what happens when I do this.
ooh, it's a perpendicular.
That's an
right?
altitude.
That's an altitude. Very good.
Big
Okay.
grant.
Yeah.
We dropped an altitude to the hypotenuse.
Hypotenuse.
From the right angle to the hypotenuse is our altitude. And what did it make?
Another right triangle.
Another right
I see
triangle.
a square.
In fact, 2
2
right triangles. So how many right triangles do we have altogether?
4.
3.
3 of them.
You do 2 times 2.
Okay? We have our original right triangle,
Oh.
we have a green right triangle, and we have a beige colored right triangle. So far so good? Okay, now watch what happens as I slide this.
Oh gosh.
Oh,
Oh lordy.
what's happening?
What does that mean?
It means those are congruent.
Those 2 angles are
So that one
congruent.
must be congruent to that.
Aha.
Wow.
Everybody see that?
Well, it's a right triangle, or if it's a triangle, it's 180, and if one side's right, the other 2 equal 90, so.
Okay. Everybody see where we are? We have 2 angles that are congruent to each other, don't we? The medium-sized angle has a red and a blue, and the small triangle has a red and a blue.
Wow.
Okay? Now watch what happens as I move this further.
What is happening?
Just reflected across the hypotenuse.
Translated.
And then we're going to reflect this one across the hypotenuse.
Dun, dun, dun.
We're going to have to do some reflections and some rotations.
Is that a trapezoid?
Okay? So far, so good? So 3 triangles, our big one, our medium size, and our small. And then watch what happens. What kind of triangles are these?
Right.
Right triangles. So what else? Similar. They're not congruent. The angles are the same, but the sides are proportional, aren't they? They're similar triangles. So when we drop an altitude from the right angle perpendicular to the opposite side, to the hypotenuse, we end up with 3 triangles that are similar. A large one, a medium size, and a small. So far, so good? Okay? So that's why I gave you a sheet with a whole bunch of large, medium, and small size triangles. They're going to help us be able to find the value of x. Okay? So here we go. In a right triangle, if an altitude is drawn from the right angle, okay, to the hypotenuse, we have 2 triangles that are going to be similar to the original. Okay, all 3 triangles are similar. Nothing to write here. Okay, everybody see where we're at in that 3rd box? Okay. Nope, you don't have to draw them because I actually drew them on the top of your paper, on your triangle paper. So we want to be able to write a similarity statement for all 3 of these triangles. Okay, so let's think about what this looks like. We have Sophie, you guys have already proven that you guys can't sit together. Okay?
Got him.
All right, big triangle, medium-sized triangle, small triangle. Okay? Which is the 90-degree angle of the biggest triangle? What's the right angle of the big triangle? Okay. What's the smallest angle of the large triangle?
B.
A. And what is the medium-sized angle of the largest triangle?
B.
Okay. Now let's look at the medium-sized triangle.
Let's do it.
Okay. Medium-sized triangle. Which is the right angle?
The right one, the triangle, yeah.
D. So D is my right angle. Which one is my smallest angle of this triangle?
B.
A.
C.
A is going to be your smallest angle.
B.
And what's the medium size?
B.
Okay. Last triangle. Itty bitty triangle. What's the 90-degree angle? What's the smallest angle? B. And what's the medium size? C.
Why is it white?
So, if I need to write a similarity statement, what in the heck are they asking for?
Triangle ABC is now congruent to triangle ADB is also congruent.
Similar.
No, yeah.
No, they're not congruent.
Similar.
They're similar. ABC is similar to
The other ones.
ADB is similar to
BDC.
BDC. The order matters once you set the first one, right? Once you choose how to name the first triangle. Okay? This is on this first box right here.
Is it still on the notes?
It's still on the notes. This is the 4th box.
It's a note type of thing.
Okay? Yep. On the similar right triangles, notes and worksheet side is the 4th box. Wait, what? We wrote our similarity statement. All that. Now, Logan chose to call it ABC, but if he had decided to go big or small, medium, large, he could have called it ACB, but then you'd have to call it ABD, and B, CD. Okay? Similarity statement. What triangle is similar to what triangle is similar to what triangle? Small,
ABC is similar
large,
to
medium.
ABB, and then ABB is similar to BBC.
Right. So rather than write 3 separate similarity statements, we can just run them all together. This triangle is similar to this triangle is similar to this triangle. Okay? So questions on this one? Okay?
Okay, yeah, let's watch for you.
I'll come back and help you in just a second. Okay? All right, so next one. So, we want to find the value of each variable. Okay, so now we're down here in this 5th box, and we want to find the value of each of these variables. So, this is where your little sheet comes in handy. Okay? We want to look at the biggest triangle and label things. So, what parts do we know of this biggest triangle? The Y is the shortest side, right? And then we know the hypotenuse is how much? How long is the hypotenuse? 11. Okay, so the hypotenuse is 11. Okay, that was the big triangle. So far so good?
So far, so great.
Now let's look at the medium-sized triangle. The medium-sized triangle is this guy right here.
8,
So 8 is the,
not the hypotenuse.
not the hypotenuse, right? It's the longer leg. X is the
Short leg.
short leg, and we don't know the hypotenuse. Okay? Now let's look at the little itty bitty triangle. Okay? Itty bitty triangle is this one. X is the
Next is the short one. Oh, no, it's the long one.
X is the long one. 3 is the,
Short side,
and Y is the
other side.
hypotenuse.
Where is
Now that
that?
we have the 3 triangles created, right? This is this box down here, but you might want to use your other triangle sheet to come up with it. I gave them to you, right?
Come on, Grant.
Gave you a whole sheet full of them.
I thought you wanted us to draw them in the
If
box.
you draw them in the box, that's good. That's good practice. Okay, but it gets extremely old drawing those triangles over and over again, right? So that's why you want to. Okay, so what the triangle sheet can do for your examples and for your assignment, right? Just label which ones you need. Okay.
How does this help us though? Why would we just draw them on here?
Okay, so why did we draw those? Okay, so we're in this is what we're working on. And we drew 3 triangles. Well, we used this. Okay, so now we've got to figure out what X and Y are. Okay, so if we look at these 2 triangles, you notice that we have, is this going to help us find X and Y? It's just got a template with a bunch of triangles, so you don't have to redraw them. You might want to use them, so you don't have to redraw them over and over. But if you want to draw 3 triangles on your paper where there's not a lot of room, you can do that. Because you guys have been talking, you've got to focus.
Wow.
Focus.
I haven't done a word in
Yeah.
All right,
Wow. Like,
looking at these 2 triangles, now that we have them set up,
Just confusing because why do we have to draw 3 triangles?
because they're all bunched together and it's hard to see what's going on.
So how are all of these all the same?
Sophie, maybe you can ask after class for help.
Okay? Look at
No,
your
I
giant.
just want to know.
Okay.
I know
look at your
that's
giant
help, it's
triangle,
okay.
guys. The largest triangle has a leg, and a hypotenuse.
Yes.
Okay? The short leg is Y.
Yeah.
The long leg doesn't have anything. And the whole thing is 11. Because we have 3 and we want to be able to figure out what X and Y are.
There's a whole one.
And the 2 little ones.
Where's?
Okay? We have a big giant triangle. And then we have a medium size and a small.
Everyone's making fun of me.
No, guys, please.
No one's making fun of me.
Yes.
Yeah,
Okay, here's the reason that we're drawing the triangles. Okay? X and 8 go together, right?
Yes.
They're the same side. So 8 is to X as
3 is just,
X is to 3. 8 to X, X to 3. That's what we did in chapter 8, right? But we didn't have triangles that were all nested within each other. So that's why we draw the 3 triangles, so we can see it and work it out. Okay? So now we've got the mean, x squared equals 8 times 3. What's the perfect square in 8?
4.
4. This is 4 times 2. So what's coming out? 2 is coming out. So this guy comes out. What's left inside?
4 times 3.
2 times 3. What's 2 times 3?
6.
6. So x is 2 square root of 6. Okay? Now we've got to figure out what y is.
Why do we got an 11 there?
Okay?
Alright, so
Because what is
3.
8 plus 3?
11.
That's the whole hypotenuse.
You didn't do anything with the third triangle.
Right. So now we got to look at these again. Okay? Now we've got to figure out what y is.
Probably 3 plus X.
And this one and this one have y's in them.
And then 11 and 1.
Okay? So the 11 goes with the y as y goes with the 3.
I could not.
Miss Bender.
What about the 8?
Okay. It's like an emergency.
Okay? So y squared equals 11 times 3, right? We want to get rid of the square, so we're going to square root. Is there a perfect square in 11 or 3? Nope, so we're just going to call it the square root of 33.
37.
So far, so good?
No, this is all way too difficult. It makes no sense.
It's abstract, right? We are used to rotating and reflecting, but they're nested together. So that's why it's beneficial to have your 3 triangles. And then in a little bit, I'm going to show you a shortcut for it. That's going to save you time.
Why didn't we just learn that way?
Because not everybody will remember them. It's a shortcut. They don't always want to memorize it.
What was the shortcut?
I'll show you in just a sec. Okay? All right, one more example of these. Okay? So use your triangle sheet to do this example. Okay? So we've got 3 triangles drawn side by side.
Where's the hippo?
Okay?
Is this on the paper?
Is on your other piece of paper.
Technically,
I could not.
So yeah,
Are
this
the
is
numbers on the paper?
yes, this is this one right here. Okay? All right. So looking at this triangle, the big giant triangle, what's the 12?
12.
that's the hypotenuse.
That's the hypotenuse. It's opposite the 90-degree angle. All right, big giant triangle. What's
Big
the
boy.
6?
6, that would be small leg.
The small leg. Okay. What's the X?
Long.
Long leg. Okay. So we've got all 3 parts of that one.
Boom.
Okay.
Wait, so what's the middle one?
Now let's look at our medium-sized triangle.
Alright, so
Medium-sized triangle is this guy.
those long legs 9.
So long leg is 9.
Hypotenuse is X.
The
Wait, is
hypotenuse,
it the
And
hypotenuse?
Y is short
the
leg.
hypotenuse on this one is opposite the 90-degree angle, so it's going to be X. And the short leg is
6.
Y
No.
of the blue triangle.
Small
Okay, what's the
one.
small
Hypotenuse
Okay,
6.
now let's look at the little one. The little one has a hypotenuse that is 6, and Y is the long leg. And we don't know, well, we do. How long would this piece be?
3.
3. Why is it 3?
12
12 minus 9, 9, that's, yeah, 9 plus 3 is 12.
What jobs is this going to be useful for in the future?
Now that we have them all set, all drawn, now we can
I
decide,
have no room to solve.
okay? And that's why I gave you the triangles on another sheet, right? So that you wouldn't have to draw the triangles over and over. Okay? So here we go. I see X's in both of these, right?
Yeah.
Where?
X and X.
Wow.
Okay? So let's write it out. We have a long leg that's X and a long leg that's,
So do we do X over 9?
yep. And then we have a hypotenuse that is,
12 over X?
yes.
Fake ways.
Well, that's not the same side of the triangle.
Okay? That's what it means. Okay, we're using these to find x. So now, x squared equals, we can multiply it out and get 108, or we can say that it's 9 times 12. And 9 is a perfect square, isn't it?
3,
So the 3's coming out. 12 has a perfect square.
4, and 3.
So the 4's coming out.
2 square root of 3.
And what has to stay inside?
4.
3.
The
9.
3. When the 3 stays inside, x is now going to be 6 square root of 3. So you can make it big and make it 108, but then you've got to break it down.
Would you do the same thing from 9, 6? Like you did x over 9 and 6 over 9, or 6 over x.
Wait, so now
6
we have
goes
to
with the
find
y.
out what y is?
You want to
But
go,
it's not the same, that's not the same leg though, that's the
We figure out
hypotenuse
what
of the
y
big
is
triangle,
now?
and that's the big leg of the other triangle.
Yep. That's what I was wondering too.
one more time, Logan.
12 is the hypotenuse of the big one, and 9 is the big leg of the other one, the size of those four legs.
So we said this x, right, goes with this 9,
Okay. Makes sense.
okay, as this guy, this 12, went with this x.
Okay, so for like the small one, you do like 9 over y, and y over 3.
Okay, so for the small one, 9 goes with the y, as y goes with the 3. Does everybody see? Okay,
Bless you.
cross multiplying, y squared equals 3 times 9, or 9 times 3. We take a square root of both sides. What's the perfect square in 9 times 3? It's 27, but we'll have to, if we,
3.
yep, we've got a perfect square. The 9's coming out as a 3. 3 square roots of 3. Do you see why we spent so much time simplifying radicals
No.
before we even started this
I
stuff?
still don't know how to do it though, so you spent that obviously.
I'm sorry. There is, and I'll show you that. Okay? So do you want to see that method right now?
Yeah.
Okay. So there's another way of doing this. Okay? If you like the 3 triangles, you're welcome to use them and they work every time. Okay? But let me show you an easier way. Okay? It turns out that the altitude is the geometric means between the segments of the hypotenuse. Let me explain what I mean by that. Okay? We had that right triangle. We dropped an altitude. This altitude is the mean between the 2 parts of the hypotenuse that it splits it into, segment 1 and segment 2. Okay? So that means that if I want to set up my proportions, the altitude is going to go where the x's did, and the segments are going to go where those other numbers fit, A and B. Okay? So altitude has to be across from itself in the diagonal. Segments have to be across from each other. And when we say segments, we mean this piece and this piece. So when we started with our big original giant right triangle, the altitude is the one that goes from the right angle down to the hypotenuse.
Okay, so whatever square.
Yep. Yep, it's either going to be a number or a letter. Okay? So that means that altitude squared equals segment 1 times segment 2.
Hold on, what are segments?
Okay? The segments are the 2 pieces that it splits it into.
Ah.
So segment 1 in this case is 5,
It's 7.
and segment 2 is 7 because the whole hypotenuse was 2. So because the whole hypotenuse was 7. So far so good? All right, so the altitude is the mean. That means that we're going to square it. X squared equals
7.
Nope.
Good
5
job, Sophie.
times 2. Is there a perfect square in 5 or 2?
No.
Nope. So x squared is 10. So x has to be square root of 10. Isn't that easier than drawing 3 triangles?
Wait.
No, how is it easier anyway?
because we didn't have to draw our three
Yeah,
triangles
we
out.
don't have to draw like two triangles anyway, because you gave us.
Exactly.
True, but then we didn't have to tear them apart and put them in the right spots, right?
So what's the formula?
Okay, this is the formula. Altitude squared
What's the altitude?
equals segment 1 times segment
Wait,
2.
where do we get altitude?
Altitude is the line that goes from the 90-degree angle perpendicular to the hypotenuse. It's the one that splits it into three triangles.
So what's x equal?
So in this case, x was the square root of 10.
Oh, wait, we're finding that?
We're finding it. Yep.
No, you
Okay.
wait.
All right, next one.
No, they need to
Uh-huh.
wait.
So like on here, so like when it gives us the whole thing at once, how do we know like what?
Good question. Okay. So let me tell you the next piece. Okay. So now, oops, one with numbers. Okay. This time, x isn't the altitude, is it? So it's not going to be x squared this time, is it?
It's gonna be the square root of x.
So it's going to be which one
That's
squared?
Wait, is there this on our paper?
Yes.
Seven squared.
Oh, wait.
What?
Wait, where?
On the back side, the second example.
Like fish.
7 squared.
So we do 7
Oh, wait,
squared.
did we just do the first one?
Mhm.
And I didn't even write it down.
Mhm. 4 times x.
That was my years ago.
Okay, so it's not always going to be x that gets squared. It's
Nope.
always the altitude that gets squared.
Yep.
So if the altitude happens to be x, we square it. But if some other number happens to be x, we square that. Okay? Now, what is 7 squared? So if 49 equals 4x, what do we do to get the x by itself? Divide by 4. 49 fourths. It doesn't come out evenly. You can leave it as 49 fourths. You can call it, what, 12 and 1/4, 12.25, but leave it as 49 fourths, it's fine. Okay? Questions on that one? You don't have to learn this shortcut. You can make the triangles or use the triangle sheet and do this. Okay? Here's the other one. You guys can work on your homework if you don't want to do it.
Where's homework at?
Oh, this is the homework?
Is it front, back?
Front and back. Okay?
So much writing.
113 on one side and 112 on the other.
Oh, wait, we have to get the back too.
Yes. And this is the shortcut method. All right, so this one says that the leg is also the geometric mean between the segment that is next to it and the hypotenuse, the whole hypotenuse. So if you want to see the second shortcut, you say, hey, wait a minute, this guy is going to be squared, and it's going to be equal to the segment that's next to it times the hypotenuse. And that's the whole hypotenuse. So it's just a shortcut that saves you from having to draw the three triangles and put things in the right spots. So if you put it in the box. Put it in the box. Okay? So let's see how it works. Okay? Okay. So in this case, we have a leg that is x, right? So x is going to be the part that's squared. It's always the leg that gets squared. Okay? So x squared equals the part that's next to it, adjacent to it means touching that angle, right? So the part that's next to it is 6. The whole hypotenuse is 10. So if x squared equals 60, well, one slight problem.
What's
6
that
times
problem?
10 is 2 times 3, right? And 10 is 2 times 5. What's my pair? 2, 15. 2 square roots of 15 is our x. So that can save you all kinds of time if you remember that the leg squared equals the part that's next to it times the whole hypotenuse. And the altitude squared equals segment 1 times segment 2. Okay?
With 48, if you radicalize it down, would it be, I don't know, what would it be?
Yep. You show one more example.
Would it be 4 and 12? No, 4 and 3.
Number 8,
4 radical 3 if you do 48 radicalized.
square root of 48. Yes. All right, last example. Okay. What part is 9?
Hypotenuse.
Hypotenuse of this one, but of the big triangle in general, what's 9?
Leg.
A leg.
Leg.
Okay.
Leg.
So this is the leg. This is the segment that's adjacent to it. Right?
Yeah.
And what's our whole hypotenuse?
That one.
5 plus x. Okay?
What in the heck is this thing, Becca?
So the leg is the geometric mean between the part that's next to it and the whole hypotenuse. 9 squared equals 5 times 5 plus x. Part next to it times the whole hypotenuse. What is 9 squared? What's 5 times 5? What is 5 times x?
5x.
How do we solve that? So that'll be 56, right? And then we're going to divide by 5, right? So 56 fifths equals x. It doesn't come out evenly. You can call it 56 fifths. You can call it 11 and 1 fifth, 11.2. Or you can call it 11 and 1 fifth. Make sense? Okay. So shortcuts or no, you decide if you want to memorize these. Altitude is the geometric mean between the two segments. And leg is the geometric mean between the segment next to it and the whole hypotenuse. That will save you time from drawing those triangles or translating the measures to the triangles, right? And setting up your proportions. Okay? Your assignment is to finish the sheet, both sides.